Two students walk into the same classroom. They get the same textbook. They get the same 100 practice problems. They study for the same number of hours. One of them memorizes every problem, every solution, every pattern of numbers that led to every answer. Ask that student the exact same question, worded the exact same way, and they will answer instantly. Change one small detail, though, and something breaks. The student freezes. The pattern they memorized doesn't match anymore, so the answer doesn't come. The other student does something different. They don't just memorize the answers. They understand why the answers work. They build a model of the underlying logic. So when a brand new problem shows up, one they have never seen before, they don't panic. They reason through it. They adapt the logic they already understand to a situation they've never faced. Same classroom, same textbook, two completely different kinds of intelligence. This is the difference between the AI you use today and something the world calls AGI. And once you see it this way, you will never look at a chatbot the same way again. Let's start with the memorizer, because that's what almost every AI system you interact with actually is. Large language models, the systems behind ChatGPT, Llama, QWen, and nearly every tool you call AI today, are built on something called a transformer architecture. Strip away the jargon and here's what's actually happening. The model looks at an enormous mountain of text, sometimes trillions of words, and it learns statistical patterns. It learns that after the words the sky is, the word blue tends to follow. It learns that after a question about Python code, a certain shape of answer tends to follow. It is not reasoning about the sky. It is not reasoning about code. It is predicting the next most likely word over and over, at extraordinary speed. Sound familiar? It's the memorizing student, just at a scale no human could ever match. And here's the part that surprises people. This student is unbelievably good at their job. Ask it something close to what it has seen before, and it performs like a genius. Ask a question that's slightly outside its training patterns, something genuinely novel, and the cracks start to show. It starts to guess. Sometimes those guesses are confident. Sometimes those confident guesses are completely wrong. Researchers call this a hallucination, but really, it's just the memorizing student, staring at a question that doesn't match anything in the textbook and answering anyway. Now think about the second student, the one who understands logic, not just patterns. That student is what computer scientists mean when they talk about artificial general intelligence, or AGI. AGI isn't a bigger chatbot. It isn't just more parameters, more data, more computing power stacked on top of what already exists. AGI describes a system that can take knowledge from one domain and apply it, on its own, to a domain it has never encountered. A system that doesn't need to be shown 10,000 examples of a new task before it can attempt it. A system that can look at a genuinely unfamiliar problem and reason its way toward a solution. The way a human child can learn one card game and then figure out the rules of a different one by watching for 5 minutes. There's a researcher named Francois Collett, the creator of the Keras deep learning framework, who spent years arguing that the AI field was measuring intelligence completely wrong. He pointed out that a model scoring well on a benchmark often just meant it had seen something similar during training. So he built a different kind of test, called the ARC benchmark, short for abstraction and reasoning corpus. It presents small grid puzzles that no model could have memorized in advance, puzzles that require actual on-the-spot reasoning. And for years, the memorizing students, the giant language models, performed terribly on it. Not because the puzzles were hard for a human. A curious 10-year-old can solve many of them in seconds, but because the models had nothing to pattern match against. There was no shortcut. There was no textbook answer to recall. They had to reason. And reasoning was never what they were built to do. This single benchmark exposed the gap between AI and AGI more clearly than almost anything else in the field. So why haven't we closed that gap yet? Why can a model write a working piece of software in seconds, but fail a puzzle a child could solve? Part of the answer comes from another researcher, Yann LeCun, chief AI scientist at Meta. He has argued for years that today's models are missing something he calls a world model. A human doesn't just predict the next word when they think. They carry an internal simulation of how physical reality works. Push a glass off a table, and you know it will fall and probably shatter, not because you memorized that exact sentence somewhere, but because you understand gravity, weight, and fragility as concepts you can apply anywhere. Today's language models have no such internal simulation. They have language patterns about gravity. They don't have gravity. That's the deeper reason the memorizing student struggles with anything truly new. They were never given a model of reality. They were given a model of language about reality. Those are not the same thing. Here's where it gets interesting, though. The gap isn't fixed. It's shrinking slowly in specific ways. Newer models are being trained not just to predict text, but to reason step by step before answering, checking their own logic the way the second student would. Researchers sometimes call this chain-of-thought reasoning. It doesn't turn a memorizer into a true reasoner overnight, but it's a step closer to that second student, the one who pauses, thinks through the logic, and only then commits to an answer. Still, even the most advanced systems today remain far closer to the brilliant memorizer than the intuitive reasoner. They are extraordinary at compressing human knowledge and reflecting it back to you with startling fluency. What they are not yet doing is what the second student does naturally, which is building genuine, transferable understanding of a problem it has never seen. And maybe that's the real lesson hiding underneath all of this. Intelligence was never really about how much you know. It was always about what you can do with what you don't know yet. Think about your own life for a second. The people you admire most for their intelligence probably aren't the ones who memorize the most facts. They're the ones who can walk into a completely unfamiliar situation, a new job, a new country, a new kind of problem, and figure it out anyway. That's not memorization. That's the second student. So the next time your chatbot answers a question flawlessly, remember what's actually happening behind the screen. You're not talking to a mind that understands the world. You're talking to the most sophisticated memorizing student ever built, reciting patterns learned from nearly the entire written history of human thought. And somewhere between that memorizing student and the one who truly understands, the next era of intelligence is quietly being built. Two students walked into the same classroom. Only one of them has learned to think.